Okay, perfect. Hello, everyone. There's not many people in person here, but there's a lot of people online. Can someone on Zoom tell me they can hear me? Okay, perfect. That was quick. Okay, so if I can go back here. We're at the 7th lecture today. We're going to do an intro to applications of AI in medicine, rather medical specialties today. You might have seen the recording of the infectious disease / public health before. If you haven't, check that out after. Dr. David Wishart actually did that lecture for us. It was a recorded lecture. And I essentially had to make him do it twice because the first time the audio did not record. So go check it out. He put a lot of effort into it. So yeah, please do that. And then this session is recorded as well. And we had the attendance tracker on. We'll just put it up again at the end. I do see a chat message. Let's see. Okay. Yeah, you should have expected that question. Okay, so today we have Genan, who's going to teach you an introduction to AI applications in medical specialties. There's a lot of activities involved. So the people in person know what they're doing, or I hope they know what they're doing, because Genan has been explaining this for the last 5 minutes. And people online, we're going to put you in breakout rooms. If you've read my message on Slack, that should kind of give you an idea. So essentially, you're going to be in groups and work on some handout stuff and 3 articles that I've shared the links to on Slack. So you can go back to that message and find it there. If you can't, just let us know, and then we'll figure out a way. But otherwise, so Genan is a PhD student in educational psychology. She has a very extensive background in machine learning and artificial intelligence. She was actually telling me the number of courses, and at some point I just lost track of how many it was. And she's also a high school teacher. I don't know how she's doing all of this, but I think we ended up having an interdisciplinary theme this year anyway, so that kind of explains it. But I think I'll hand it over to her to tell you about AI applications in medicine.
So, hi everyone. I think Hassan introduced me, and I already talked to you at the beginning. So our lecture today is very simple, and I will show you what are the purposes of this lecture. And we will have some activities during the class. We have 2 groups, the group of Sinning and the group of, can you say your name, please? Oh, a group of Alejandro, right? Yeah. So these activities, like at the end, we will choose one group who's the winner. Hassan is going to track the points. When I say like this question, like there is points for this question. So all what I need is the leader to raise his or her hand, and they say ready. So we are ready to answer, but don't answer without raising your hand. Okay, it will not count. Okay, at the end, the winner group will get the gift. Hassan has some ideas also for the prizes, but I don't know about it. Okay, so we have some questions on the slides. At the end of the lecture, all what we said on the slides, you will be applying that on the articles and the handout. So if someone is not focusing now on the slides, it will be difficult for them to answer the handout activity. There are 3 articles with the handout, and you need to answer the questions based on these articles. But if someone like is not focusing now on the slides, it will be difficult to answer. So what I would recommend that don't distract yourself with the many details in machine learning or in these articles. Just focus on what I have highlighted for you. I have highlighted the important information that you will need to answer the questions. So our lecture today is about AI applications in medicine. And why this is not working now? Okay, so these are the learning outcomes. That means what we are going to learn together by the end of this lecture. Distinguish between types of machine learning, understand basic machine learning concepts that are required for this distinction, identify the suitable machine learning type or model to solve some problems in medicine, classify machine learning problems in medicine into classification, regression, or clustering. This one is the most important one. So pay attention for this. Describe some medicine problems that can be solved by machine learning and recognize how machine learning models are used in medicine literature or research. So this is the content of the lecture. We will start by reviewing some concepts, then why machine learning is used and machine learning types, then applications of machine learning in medicine in the three types that I mentioned at the beginning: regression, classification, and clustering. For each one, we will see an example of the models that we use, because we can use many models for regression or for classification and so on and so on and so on. So we will take only one of these models. You can see it in the articles attached. And at the end, there is also an activity. So here's the, like, just like a review. So I don't want like formal definition. I just want your understanding. What does machine learning mean? Unlabeled data, labeled data, attributes, and I also provided this data to help you understand these. Okay, attributes, instances, categorical variable, continuous variables. You can discuss with each other, and once you are ready, just the leader say ready. Okay, no formal definition. Just tell me on this data, for example, is this data is labeled data or not? Are these categorical variables or continuous variables? And that's all. That's all. I don't want like a formal definition. Sorry. Just for the articles, maybe it will be difficult for you because you need to track them when they answer to give them points. Yeah. Yeah. Did I give you a paper for the groups to give points? Yeah. Which group is ready? Which group is ready? Yeah. No. Don't go to the details. These are just like concepts. And I want you to show me, for example, is this data is labeled or unlabeled? Labeled data, unlabeled data. Where are the instances? Are these variables categorical or continuous? These variables, but don't pay attention to the details in this data. It's not important. No, you don't have to. No. Great. That's great. That's great. Here's lenses classes or class. No lenses, soft lenses, hard lenses. Here's the classes. Yeah, great. That's great. Class level. Great. So this is the outcome or output variable. Excellent. Very good. Do you want to continue explaining some of these? What does labeled, or is this a labeled or unlabeled data? Great. This one is a labeled data because here is the label or the classes. Great. What are the instances? Where are the instances? What does that mean? Each row, very good. Each row is an instance or case or a patient. Very good. So the features or predictors are age, and all of these are predictors. And this one is the outcome or the output. Okay. Machine learning is the algorithm that will learn from this data in order to predict the outcome variable. So the point for group of Sinning, Ihsan, Sinning group has 1 point. So why is machine learning used? Why? Because we want to have some learning results that we can classify them into 2 types. So machine learning can be used to give us some predictions here. Oh, sorry, what I have done. Yeah. Thank you, Hassan. So we want the algorithm to give us predictions, or sometimes we want to understand something in the data, understand relationship or associations, or understand something in the data. So this is the second way we use machine learning. So here, like a summary of machine learning types, and this is the most important slide that you will need for answering the articles. So basically, we have 2 main categories or 2 main types: supervised learning and unsupervised learning. Can anybody or any group explain what we mean by that? Great. Great, Arash? Yeah, thank you. So we're grouped. Can you say your name again? Yeah. Yeah, I'm going to repeat the answer. So supervised learning, you can see here, prediction on labeled data, and unsupervised learning find patterns or relationships or associations or understand something in the unlabeled data. That's the main difference between them. So we have just now explained what we mean by labeled data and unlabeled data. So the unlabeled data, we don't have the last column, the outcome or the output, or sometimes they call it the target. Okay, but in supervised learning, we already have the label, the output or the outcome or the target variable. We have it. So the model is going to predict the label or the class. Sometimes we say the class, predict the class label. Here, we don't have labels. We don't have that, the last column. It's not exist. So what we want to know to understand associations, patterns, information in this data. For example, if there is an association between, for example, liver disease and drinking alcohol, for example, based on the blood test. Okay. So we'll go here to the supervised learning. We will find 2 main categories: classification and regression. So this one can solve classification problems and regression problems. What is the difference between these 2? Great. 1 point for Sinning group. So classification the predictions are categorical. So we want to predict those patients, like if they have liver disease or heart disease or not. So the first class is to have the disease. The second class is not to have the disease. Okay. The regression, the prediction are numbers. For example, the concentration of the sugar in your blood, it's numbers. Okay. So the difference between them, here we predict numbers, and here we predict classes or categories. That's the main difference. But can you see something here? Here are examples of the models that we can use for regression or classification. Can you see one model that exists in both? Which one? Excellent, the neural network. Because some of them can be used, one point for, what's his name? Okay, so I would say, that's it. Thank you, I'm so sorry. Okay, so.
I want to record your name and put your phone, then you can get everything.
Although he's the leader and his name is written, but it's written in a different spelling. Okay, so for example, some of them can be used for both, and some of them can be used only for one of them, classification or regression. So let's move to the other main category, unsupervised learning. So we said that the data is unlabeled. The last column does not exist. So one of these types is called the clustering. There is another one, dimensionality reduction, but it's not relevant here. Clustering, and one example is k-means clustering. This is the name of the algorithm. What does clustering mean in your basic language? Just explain what you understand from the word clustering. Great. Very good. Very good. 1 point for sinning group. Excellent. We have the data, but we don't have the labels, right? But the model is going to learn, then categorize or cluster the data points based on similarity into groups. So that's why we call it clustering. Cluster it means like a group, but smaller groups. Those groups that are similar, have some characteristics that are similar to each other, are going to be together. So the clustering, I will see like groups that have the same or almost similar characteristics. So here we will take them one by one. Regression first, here, regression. Don't look at this because this one is related to the article, which will be at the end. Now just focus on these questions and this data. This data, diabetes risk prediction data set, okay? And it's for a regression. Here are the predictors, and here is the outcome or the output, or sometimes we call the output variable. So I just want you to discuss with your group these questions. Are very simple questions based on this data.
People are in their breakout.
Great. So if you are ready, just raise your hand and say ready.
Ready.
Oh, great. Sinning group. Okay. Can you read the question and answer, please? 9 rows. These are the instances. Okay, and the features? 1, 2, 3, 4, 5. Okay, very good. What? Yeah. Oh, did you discuss only the first one? Okay, okay. Give them one point. Are you ready for any question? The other group? Just one or two questions. Okay, yes. Yeah, can you say the name of this? Risk prediction, very good. As the outcome, or sometimes they call it the output or the target, it's all the same. And what type? Is it categorical or no. Numeric, very good. Continuous, very good, because it's numbers. That's it, because it's numbers. Another point for
For the person's room, you can't pronounce it.
and anybody can answer, any group can answer the other questions? Yes, please. Yeah, what type of predictions, categorical or numeric, can this data be used for? Numeric, very good, because it's here, numeric. And can you answer the other one? What problem a machine learning model can solve using this data? I mean, regression, classification, or clustering? Very good, regression problem. 1 point for group number 2. Okay, we will come back to this article later. What's wrong? Yeah. So here, the second type, classification. And this is the same one that we saw at the beginning. So these are the same questions that we have on the previous slide. Which group can answer the same questions, but of course the answers will be different? Ready for all of them? Yeah, it's very simple. Yeah, you can, of course.
How many features and instances? 4 features.
Features 1, 2, 3, 4, 5. Okay. What type of features? Categorical or continuous? Categorical, very good. And what is the outcome or the output? Very good. The type of, or the class, sorry, of the lenses. Very good. And what type of? Very good. Categorical. This one, these are categorical. Then it will be classified into 3 categories: soft, hard, or no lenses. The last one, what problem? Very good. Classification problem. Yeah, very good. 1 point for the listening group. I'm not sure why this is not working now, but I can start. Yeah, I'm not sure why it's not working. The pointer is not working. So this one, for the clustering example, and here are 2 data, but be careful. There are some manipulating questions here, are not correct. I'm just manipulating you, okay? So if the question is not correct, you can say this is not correct, okay? Those data sets, we will discuss that, but I will give you like a question about them. These are the same, but there is something I will talk about later. There are maybe 2 questions like for manipulation. Very good.
What type
How many features?
we're answering?
Yeah, all these questions. Yeah. Yes, please. No. They cannot lose. But group number 2 are going to answer, please. So the features here 4, and the instances, how many? 12. Very good. What is the outcome and what type? 1 minute, they are answering. Do you know? Yes. Very good. Excellent. Clustering, it's for grouping, is creating some smaller groups, but we are not going to predict something. It's to understand the structure or the relationship in the data. So this is a manipulating question. We will skip this one. And can you continue that group? What type of predictions? Is it manipulating or is it? No. What type? Can we say predictions? Yeah, we cannot say, and we are not predicting. We are understanding the relationship in the data. Okay, we're not predicting something. We are not predicting numbers. We are not predicting categories. So this is a question for manipulation. Okay, what problem? This one is a good question. What problem a machine learning model can solve using this data? But we will give one point to group 2, and then clustering. Very good. Clustering problem. So look at this data and this data and tell me which one is before the clustering and which one is after the clustering. So we have the data, then we give it to the model, then the model created the clusters. Which one is before clustering and which one is after clustering? Oh, both you can get the points. Okay. Group number 2, we will listen to the answers. Very good, very good. And focus on them because I have other questions. And do you have the same answer? Okay, 1 point for each group. Okay, now here the ID of the patients, okay? And here, what happened? How many clusters we created or the model created?
3.
Very good. 1 point for Sining group. 3 clusters here. Okay. There is now a more difficult question. In people age between 75 and 80, okay? Here are the diagnosis cause, like maybe like disease or something they diagnosed by, but these are the codes of diagnosis. So people who are between 75 and 80, can you name 1 or 2 diagnosis codes that are exist for each person, for each patient? Yes, please. Yes, excellent. This is one of the diagnosis codes that each patient has. Here, 250, 250, 250, and 250. You can see it. So that's the benefit of clustering. We can see in this group or this group, people in this age between 75 and 80, the most common, for example, diagnosis codes could be the 250, and there is another 2 also, but these are the benefits of clustering. We can understand some information from the data, but we are not predicting, okay? So this is an activity now. There is 3 points 1 point for each question. Read it and say ready if you are ready.
Actually, no, online.
Online?
Okay, I would like to attempt to answer the first question.
Sorry?
So I'd like to attempt to answer the first question. What are the categories of the outcome variable? I think there are just two categories: survive and not survive.
Excellent. What type? Do you know the other one? Oh, it's one answer, one question. Anyone is raising?
For the second question, what
Okay.
type of ML can solve the problem? So we can use classification algorithms such as
Very good.
random
Very
forest.
good. Classification problem. Excellent. And the last one?
We can use random forest.
Random forest can be used,
ML.
but they didn't. Maybe
It's not
I
in the
didn't.
options.
Maybe you
RNN,
didn't study
yeah,
random forest, right?
RNN can be used. RNN.
RNN, very good. Neural network, KNN, k-nearest neighbors. All of this can solve it. Can solve this classification problem, and it will classify all the cases into survive or not survive. Okay, so it's a classification problem. Very good, excellent. So now we will go to the articles and the handout. Did you download them? Are these ready? Yeah. Oh, by the way, this DataCamp is a very useful platform or website. I learned about 22 machine learning courses on this DataCamp, and it's really, really useful if you want to know more about how these models work and how to code or create these models. To learn coding for these models, you can learn from datacamp.com. Oh my God, what I have done. So please go to the articles and the handout and start with article number 1. And if you are ready to answer the questions for article number 1, raise your hand.
Give them time. Do you want to give them like 5 minutes or something for each article?
Yeah,
Okay.
it could be like 5 minutes for each article, but we will stop maybe after each article, or do you want them all of them together? It's better for you? Okay, okay. So you have 15, we don't have 12 minutes because we want to discuss the answers. We have 12 minutes for the 3 articles. I have highlighted all the important text. You will find the answers in the highlight. Be careful. The answers are in the highlight. So for this one, 5 points for each article. 5 points for each article. So should I share this handout with them?
I mean, you can only share it to people here.
Now the online cannot see this.
No,
Mm,
but that's fine. They have it.
okay, no problem. So if you have questions, you can ask me. You can ask me if you have any question. Okay? All the answers are highlighted. All the answers highlighted. You don't have to read the article.
We have to get the answers for all three.
Yeah, but the online, we cannot switch. It's better one by one, but it's not easy for him to switch all the time. Yeah. But you can divide them between each other. Yeah, for example, you work on number 1, 2, 3.
Yeah.
If you want a faster way, you can divide them. You work on number 1, number 2, number 3. That's what they did. Alejandro, right?
Yeah. We got
I'm memorizing.
it.
Only 7 minutes remain. 5 minutes remain.
Three? No, true. Article three.
Okay. Great. Great. And did you like review with each other that everything is correct?
Yeah, this is the review.
Is the reviewer? So each one is going to talk about one of the articles, right? Yeah, okay.
Was the best lecture.
Are they online working? Are they working on this?
I think so. I'm hoping they are. Well, I don't think all of them. have.
Yeah, one group finished before the time, Alejandro, right?
Oh.
Alejandro,
There you go. There you go.
Alejandro finished.
Um,
4 minutes. Finished? Oh, great. Yeah. So we will start with Alejandro group because they finished first. So Alejandro group, could you please just read the questions for Article 1 and give the answers while you're reading? Yeah. But if you can read louder because the online cannot hear. Excellent. This study aims to predict glucose concentration using support vector regression model. Very good. Continue. Very good. Excellent. Why did you say it's continuous? Yeah. So we are expecting numbers or categories. Very good. Excellent. So the machine learning problem in this study is a regression problem. The outcome variable in this study is continuous. That means numbers or percentages. Very good. And the last one? Excellent. Very good. 5 points, please, for Alejandro group. Finally, at the end of the class. Very good. Excellent. So we will give the chance now for the second group, but we will come to that group again because they finished first. Yes, please. One of you can read.
The goal of the study is to predict heart disease using a number of predictors such as age, gender, testing time.
Excellent. The goal of this study is to predict heart disease from the title of the article, using a number of predictors such as, and you have so many in this article, but for example, chest pain, blood, blood sugar, age, gender, and many others in this article. So the second one.
In this study, Genan Hamad used to solve a classification problem. The model classified patients into 2 labels, 1 equals disease and 0 for disease.
Excellent. Can you continue? These predictions represent?
These predictions represent the
Excellent, very good. Outcome, output, target, it's the same thing, okay? So again, excellent answers. In this study, Kenyer-Schneber's algorithm was used to solve a classification problem. The model classified the cases or the patients into two classes or two labels. The first one, number one, those who are suffering from heart disease, and 0 means those who do not have heart disease. And this classification is, or this prediction is what we call the outcome variable or output or target, so many names, okay, or class labels, whatever. Now we will go, excellent Sinning group, 5 points for Sinning group. And now we will go to Alejandro group.
There's someone online.
Oh, someone online? Okay. Can they answer all the questions for the Article 3?
Yes, we can try.
But not one question, all of them?
Yeah, let's see. I didn't see the rest. Okay.
Okay. Okay. Can you start, please?
Okay, yeah. Only what type of ML problem does this study aim to solve? It is a clustering problem.
Can you hear him very well?
Yeah, it's a
He said
clustering problem.
Yeah, very good. Clustering problem. Now we will move. Yes.
K-means clustering algorithm is categorized under supervised or unsupervised learning. K-means algorithm is an unsupervised learning model.
Very good. Unsupervised. Very good. Unsupervised.
We use clustering model to dash a large data set into dash. So we use a clustering model to group a large or divide a large data set into smaller groups where each group has similar features or dimensions.
Excellent. Excellent. We use clustering models to group a large data set or categorize it into groups, a large data set into smaller groups where each group has similar characteristics or features. Excellent. Can you answer number 4?
Yeah, we can apply K-means clustering algorithm to cluster the large data set which contains common variables or features.
How many?
It could be from the article. I didn't know the number. I didn't check.
Okay. You can continue, no problem.
So, which contains features or variables of. Come on, I'm lost. I can't answer that. Thank you.
Okay, no problem. We'll give you half of the points. It's 5 points, so we'll give him 3 points.
Thank you.
And Alejandro group, please, can you answer number 4?
Yes, so by the clustering algorithm, it's very learn how to understand and associate relationship between excessive level.
Very good, excellent. So we can apply we can apply K-means clustering algorithm to cluster the liver disease data set, which contains 7 variables of blood tests to understand the association or relationship between alcohol consumption and liver disease. And please give them 2 points for this one. And can you count the points for all of them? Yeah, so if you have any question regarding these 3 categories, clustering, regression, and classification, you can ask the question now, or you can send it by email, whatever you like. Which one is the winner?
Who do you think?
Not sure. Maybe Alejandro group. Really? Can you announce?
I almost was gonna be like the group you don't know them.
Can you like just tell them how many points for each
So
group?
you got 13
Oh,
and the sitting group got 11.
very
Houston's
close.
group got 5.
Excellent.
Their group was, and Bennett's group got 1.
Oh, that's from the online. Great. So Alejandro group, do you like this one or this one? Which one? This one? Oh, so each one of you maybe can take one, maybe. Sorry, two. Yeah, but you have done like a great job. So you're not going to get two. They are going to get two, but you are going to get one only. Yes.
I want to keep it a little,
Sorry.
the mic is picking up. Oh, sorry.
Yeah, I finished now. But if they have any question, you can use it again.
Okay. Oh, the TAs are also getting something. Okay. Thank you. Apparently, I also get chocolate. Are there any questions online? I'm just looking to see if there is any. Yeah, that's what I'm looking at to see if there is any questions.
Or if you remember a question, you can send it to my email. Or put it on the slide.
Yeah, just, okay. Yeah, if there are no other questions, we can close today's session. But yeah, if you have any questions later, just send it over Slack. And I'm sure Gina would be happy to answer. No, surprisingly, no questions online. So either you've convinced everyone or everyone's confused. One of the two. I'm gonna bet it's the first one, but we'll see on Slack if there are questions. Okay, with that, I am actually gonna put up the attendance tracker. Wait, where is it? Okay. They could have done it in the beginning or now, it doesn't matter. I'm just gonna put this on. Okay. And then, yeah, if you have any feedback, actually, before I forget, I'm going to post the survey link again on Zoom. Before I forget. And those of you in person, check out the survey link on Slack, because it's not going to be open for too long. I think I might close it tonight or tomorrow. That's the midpoint survey. If you haven't filled it out, go fill it out. And you have the option of opting in for a prize draw at the end as well. So it's good for us to kind of hear what feedback you have, and you can also opt in to get a prize as well for that. And with that, I think we will close today's session. Next week, we'll talk about applications of AI in neurology and neurosurgery. So neuro people, make sure you come in prepared. But otherwise, thank you so much.